So, this is the logic of the dot product. Here we have the equation for dot product, and actually it is calculating this area here, which is from the length of the vector A here, and then we have C, which is the projection of vector B on vector A. This is called the vector projection. C is vector projection of vector B on vector A. Alright, you might ask how it is obvious that this area here is what the dot product is calculating. Let me explain. Here we have the rules for sin, cos and tangent. Now, here is the triangle that we have earlier here. This triangle is taken from here. We have C here. So in a principle, if this would be 1, this would be 2, if this would be 5, we would get sin like this, cos like this, and tang like this. From this we want cos, since we have this here and this here. This was the length of the vector B, and this was C in our calculations. We can verify it here. It was C and it is length of vector B here. Alright, let's go and look at it then from this perspective. Here we have the triangle C and length of vector B. Here is the angle. And by the way, usually this equation can be also given like this. This marking just means angle between these vectors, and since I have marked that angle here with alpha, I'm just gonna use this form since it's a bit more easier to understand. Alright, so we go back here. Now we are calculating using the cos to calculate what would be this C, what would be its value. We take cos alpha, which is this from the previous reasoning, this divided by this. We have it here. We multiplied, let me correct myself, we multiply both sides by the length of vector B we got here. And since by multiplying both sides we have dividing and multiplying, which cancel each other out since they are the same multiplier and divider, they cancel each other out. So we are left with this, and if we just switch the sides, we are left with this. Now this was the dot product, what we first started to figure out what is it doing. Now, does this look kinda familiar? It looks like kinda that C is this section here. This section here is calculating the value of C here. It means this length. In other words, C is the projection of vector B on the vector A. Projection means you can think about projection as if, let's say, for example, we have a sun here. So it's a shadow of vector B on vector A. Here we have the sun. So C, which is the projection of vector B on vector A, is, you can kind of think of it as a shadow of this vector on this vector. When the shadow comes perpendicular toward this vector A, perpendicular, I mean this word. Alright? So we solved the C, which was this length here. Alright? Now we go back. Not to back, but forward. And we get here. We had the equation for the dot product. We also already solved C, which was this part of the dot product. So we can mark this part with C. So we are left with this. Now we can see that dot product is actually just multiplication with the length of vector A with C, which was the projection of vector B on vector A. And so by we get this shape here. And why I marked this here? Well, we can go back to the first picture. Here was the vector A, and there is a circle, and the middle of this circle is the point where the vector A starts. So if we just rotate vector A here, we can see that this line is also as long as the length of the vector A is. So I could say, I can say that here this side is the length of the vector A, and this is the length of C, which is the projection of vector B on vector A. Alright? So now we are calculating this area, since we are multiplying its sides. And here, and now you can understand that when this angle grows, it means that this is coming up and up and up. And when it does so, this area gets smaller and smaller and smaller until this vector B is perpendicular, this word, to vector A, in which case the projection of vector B on vector A is 0, meaning that if there would be sun here, if there would be sun there, the shadow it would cast of vector B on vector A would be 0, since it comes directly above. I made a little animation for you guys. Here we have it. Alright, here we have an animation for you guys. And now you can see that when the vector A starts to move, you can see how this area will go to 0 when it's perpendicular to this vector. And this area was what the dot product was calculating. And this is the logic of the dot product and its geometrical explanation.